Today, we're going to be talking about enterprise blockchain application security and privacy, and we're going to keep it simple. There's a school of thought that this is an emerging technology and this is fairly new. So therefore, what are the security considerations? What are the privacy considerations? Or what makes this technology so secure? So this is what we aim to talk about in this presentation. And then on top of that, we also need to put into consideration what does a real end-to-end solution look like that just so happens to be using blockchain, right? This is the way that we should be looking at it. We should be looking at the solution that we implement for whatever the business purpose, not as a siloed piece of technology, but integrated into the entire end-to-end stack. So this is where we're coming from over here. So we know this is getting into the summertime. Most slow down. We're still staying on course. Just to let you know the upcoming schedule for July 2019, we're going to be doing our webinar on July 25th, where we're going to be talking about adding value to blockchain value, an overview of hybrid blockchains and interoperability. We're going to be doing an executive roundtable on July 10th, 2019, which is on use case patterns. We're also going to be holding an enterprise blockchain immersion experience on July 17th, which is our 1-hour virtual, relaxed, educational, and guided tour of today's blockchain technology. And then we also have our training session, which is on July 24th, where we're going to be talking about the Microsoft Azure blockchain service. Please note that all these events, if you happen to be in the New York City area, we can host you there, or at the same time, all these events are going to be virtual as well. So no pressure in coming down in person. If you want to take it from the comfort of your desk and learn with us, we're more than happy to accommodate. So that's upcoming schedule for July 2019. We definitely hope to see. Now, just for one quick second, what we do, Envision Blockchain. Envision Blockchain is a full service consultancy and blockchain system integrator, where we provide blockchain services, which focus on developing proof of concepts. They take the proof of concepts and then build them, moving from the proof of concept over to pilot and then production and then sustaining that. That's what we're calling MVP development. We also do application functional and technical requirements and smart contract development, which we'll talk a little bit about that. And then also mobile and web UI, UX. Can't leverage this technology without a way to actually interact with it. At the same time, we'll be talking a little bit about this, the solution testing, the monitoring, the reporting. And then there's also, once you've gone live, you need to be able to support the infrastructure, provide this advisory services across your business network. And then of course, once you go live, you want to be able to train the users and the members of the consortium or the application users. We're going to get into this in a second, but in order to provide blockchain solutions, there also needs to be the modern cloud and on-prem solutions, from IoT device to blob storages, data warehouses, Kubernetes and Dockers, and infrastructure as code and microservices, and obviously line of business applications. I mean, this is where we talk about the entire end-to-end stack of the solution. And then in order to understand all this, we provide the different workshops, such as the immersion experience that we explained, and use case analysis, and devoting a full day for your organization and a discovery day to really isolate the use cases and come up with a really good functional and technical requirements. Want to highlight 2 workshops at the bottom: benefits of zero knowledge proof, second layer privacy. We'll get into a little bit in this webinar about that. And then also decentralized identity management, providing a workshop so that you can understand how identity in your use case can be decentralized and what are the benefits of that. You know, just kind of thinking out loud, we always get the question on, well, what is a blockchain systems integrator in the first place, right? It's a little bit, we understand SIs, system integrators, we think we kind of understand blockchain, but where's this blockchain system integrator? Well, When you take a look at all the different infrastructure that's in your organization, you have web apps, you have ERP systems, you have different databases, and then now you can also go ahead and include a blockchain into the stack. Us as the blockchain system integrator, we've partnered with different blockchain solutions, and we've also have this experience with system integrating. So when we combine the both, it's good to have someone that understands this emerging technology to be able to integrate systems. For example, you have a use case where data is hitting your ERP. You need to trigger different data to go into a data warehouse, and then a different data goes into a web API so that your developers can go ahead and utilize that. And then at the same time, it also needs to be able to hit a blockchain ledger, and then the information from the blockchain ledger comes back into the web API so that your team can go ahead, or us, and write information to the web API that the team needs to use. And then all that is based on microservices architecture and contained in Docker, and it's orchestrated via Kubernetes, and it's sitting in different cloud platforms. And we develop it by using DevOps methodologies and frameworks. This is what we talk about a blockchain system integrator, who can actually put all these pieces and orchestrate it and integrate it the right way. So that's what we do from a 30-foot view. But again, we'd love to chat more about that. So now getting onto this topic, an end-to-end blockchain solution dissection. So let's just for 1 second dissect by what we mean by an end-to-end blockchain solution. So at the very beginning, at the very base level, we have our cloud platform. You have your databases, your containers, your integration services, etc. That's nothing new. Let's call that in orange our existing technology. We've already got all these cloud platforms approved for our business. We've already pen tested them and stress tested them, and we've already started to migrate to the cloud, right? Because now we trust it. But now there's this new technology coming in. We call that, I don't know, let's call that the blockchain network, number 2. So the blockchain, the blockchain network is essentially the infrastructure, this decentralized nodes that we talk about. And then we have another layer on top of that we call our smart contracts. And smart contracts are essentially programs that you develop, and we'll get into that a little bit, but that needs to be deployed to the blockchain network for you to be able to interact with it. And on top of all that, we have our line of business applications, our user interfaces, the web apps or mobile apps. And we also color code that in orange because, again, this is nothing new, right? Your ERP has already been tested within your organization. You trust it. You trust it to be secure. Sure, there are leaks that happened, and we don't have to go and name all of them in this webinar. That's not the point. We can all do a Google search and find out where the leaks and what systems. But let's just say that this has been an existing piece of technology. So between the cloud platforms and the line of business applications and the web apps, et cetera, let's just go ahead and say that this is new, this is nothing new, rather, and this is existing. And what's in the turquoise, the light, and the dark, this is our new technology. So just to cover our bases, what we're going to do is we're going to cover the cloud platform. We're not going to spend a lot of time on here, again, because this is nothing new, but let's just talk about the security, because remember, this is going to be part of your end-to-end blockchain solution. This is kind of the first diagram that we showed you with what does a blockchain system integrator do, right? You have data going into ERP, it's sitting in a cloud platform, you have a web application, you have different integration services or web jobs. So, when you think about how we got to where we are, it started out as a major concern. A lot of organizations did not want to get into this sort of cloud infrastructure, but now this has turned into a major initiative. Organizations are looking to save money on moving to the cloud, and there's added security when you move into the cloud because there's no central point of failure. And then at the same time, you have government organizations that have mandated that all their infrastructure eventually be moved to the cloud. So when we take a look at enterprise requirements, there's no difference from small to big, but number one, they need to be scaled. You need to have low latency. You need to have this confidentiality of data, and you need to be able to govern and manage this. So in order to do this, And I'm just going to take Microsoft an example, because if you take a look at all the cloud platforms from AWS to Azure to IBM, they're all going to have similar statements. But there's a white paper, there's a link on the bottom of that, that talks about Azure that I'm just going to go ahead and pick on. And there's 4 different sections, but we're going to just focus on 2 for purposes of this. So the first one is that they say that it's a secured platform. So how is it a secured platform? Well, number one, you have this security development cycle and internal audits. This is a framework that helps develop solutions with the best-in-class security considerations. There's frameworks, there's guidelines that Microsoft has provided, such as security training and definition of the security requirements when you're beginning your SDLC, and coming up with different metrics and compliance reporting, and they perform the threat modeling, etc. And this is all part of this security development cycle and all the internal audits. They also provide mandatory security training and background checks. And there's a formal response in a white paper that Microsoft put out there to kind of help answer this. But they're basically saying that we've had all of our engineers go through this security training and background checks, and this is how we know that it's built based on our secure training. They've also provided penetration testing for everything that is being launched into the marketplace, and intrusion detection and DDoS attacks and audits and logging. They've already covered all that. And they also claim that all the data is now being stored in this state-of-the-art data center with all sorts of physical security security considerations, where there's 54 Azure regions available in 140 different countries. They make sure that all the right individuals are allowed into this data center, and if they're not the right individual, you're not allowed in. And they also go in how they handle security incidents response and shared responsibility. When we talk about the privacy and controls, obviously there's the quote that they say that you manage your data all the time. So there's Microsoft agreements that the use of the data that is stored on their infrastructure is not to be used for their own purposes, right? We have that sort of protection. You can control on the data location, so that there's strict rules, again, on the facility of the data centers and where they're located, on who's allowed to come in, and then also provide data access on your terms, where you're going to be able to store the data, and then have all this different access control within the Azure apps in order to manage all the different resources. Okay, so let's get on to the next one. So now this is what everyone is here to talk about. So now let's talk about the blockchain layer. In purposes of this, we're talking about this first layer. Even though this is number 2, when we're talking about blockchain, let's call this level 1. I know it's a little confusing with the number 2, but this is our infrastructure layer with regards to a blockchain network. So let's talk about this. And I just want to reiterate that we're going to assume that everyone is already past the what is a blockchain stage. For this particular conversation, we're not going to talk or focus around what is a blockchain. We have different training lessons and immersion sessions that we cover what is a blockchain. So we're just going to get into this. So if there's any terminology that you're not familiar with, please feel free to put that into the chat. We'll make sure that we'll go ahead and address it, but we're going to cruise right through. Secure platform. So when using an end-to-end solution, the nodes are deployed in a virtual machine that are hosted in a cloud platform, Azure, AWS, etc. And here's a couple screenshots. So again, you put your infrastructure, you put your different nodes in different virtual machines that are hosted in the cloud platform. So again, this is why I wanted to cover at the very beginning the security implications of the cloud platform that you have already began to trust. Whether you trust it fully, that's a whole nother conversation. But let's lightweight say that you trust the cloud platforms these days. So now it's sitting in the virtual machine. right? And you're kind of offloading your downtime, your SLAs over to Azure, all right, or over to AWS. And this is an example of Hyperledger Fabric nodes actually that are being deployed and sitting in different virtual machines. We also have another screenshot if you're familiar with the brand new Microsoft Azure Blockchain Service. This is also sitting in Microsoft Azure. It's sitting right within your tenant. You can see there's different access controls, the IAM on the left side, and they're also sitting in different virtual machines. And then we also have another screenshot if you're familiar with the Microsoft Azure Blockchain Workbench. Here is a screenshot of the resource groups, and I just highlighted the virtual machine scale set. That's where your blockchain nodes are sitting in. This would be the quorum nodes, or you can also put it to well, it used to be the Ethereum nodes. Now it's the quorum nodes. But essentially, as you can see, this entire infrastructure is your kind of proof of concept, POC, pilot, if you will, application that the Microsoft Azure Blockchain Workbench aims to be. And, and I think that this screenshot also shows a little bit about this entire end-to-end blockchain solution, where it's not just a blockchain and there you go and there's your app. You see there's, just to call out a couple of them, see you have your disks, you have your event grids and the key vaults, you have load balancers and network security groups, service buses and SQL databases, and then the virtual machine where the blockchain application sits. This is the next piece. The next piece of the blockchain layer, what adds to the security is every legitimate transaction is confirmed by participants on the network in what is called a consensus algorithm. So we're going to get into this in the next couple slides, but all of these different squares, see we have 6 squares, say they represent different nodes in your blockchain ledger. And because of that, they all operate in what's called a consensus algorithm, meaning that as information gets sent to the blockchain ledger, each node has to confirm the validity of the transactions. And because the consensus algorithm is such that every participant in the network has to agree, even though that they all take turns in different consensus algorithms to go ahead and validate it, they cross-reference each other in a way that allows only the approved transactions to get put through. So when the consensus algorithm hits, all the transaction metadata from that first node has now been decentralized and distributed to all the other nodes and participants. And then of course, if this is a round robin type of a consensus, then the next node gets a chance to go ahead and validate the transactions. And when it's a valid transaction, the same information is being sent through. And likewise, and we can keep on going down until, indefinitely. So again, consensus algorithm keeps the blockchain network a secure platform. Decentralization. Now, I think that this is a really, really key point in here. So the larger the network, the more value the network gets and the more secure a network gets. And what do we mean by that? Well, I think this is the easiest and simplest, best way that I can explain this. So for example, let's say that we have only one node in our blockchain network, right? Again, blockchain is only made specifically for when there's more than one business network. Otherwise, you could just use a central database, and I'm going to show why. So for example, right, in the previous example that you could still deploy a blockchain. I mean, technically, you could deploy a blockchain with one node and it's capturing the transactions. Now, let's say that you're a business or you have users that depend on this particular set of transactions. And let's say that you've been building transaction metadata on this one node network for some time. And all of a sudden, something internally happens and you decide that you're going to go ahead and just tear down the network. And then you're going to go ahead and rebuild the network and change the metadata. So now, who's to say that this is a trusted source of data, right? This doesn't look too secure. But look what happens. As you start adding more participants to it, if that same node or that same organization decides that they want to turn this down, and spin it back up, well, you still have the second node in the network to say, no, this is not what was first captured. See, you tore it down, you brought it back up, and it doesn't match the transaction metadata that we first originally caught. And you can now imagine if that provides that much more security and trustworthiness, imagine what happens when you have now 6 different nodes that are participating. The value comes up exponentially. And we take a look at it. This is why organizations have said, well, the public blockchain is that much more secure, because this is only a 6-node network that I just demonstrated this. You know, if you take a look at the Bitcoin network or the Ethereum public network, I mean, we're talking about, you know, thousands and thousands of nodes up there, where if one shady character decides to go ahead and change it, well, the rest still show it. And when we talk about privacy and controls within blockchain networks, see, we have a couple different ways. We have 3 different models that we can choose from. You have permissioned ledgers, such as Enterprise Ethereum and Hyperledger Fabric and Corda, and there's Quorum, which is not being shown right here. And in a permissioned ledger, see, all the transactions that happened are visible, but only to those that are permissioned to get into the network. Whereas there's a permissionless network that I was just talking about, the public blockchain networks, where anyone can go ahead and join, and everyone can see all the transactions and all the metadata. And there's a reason for that, where blockchain is made to be transparent. But then you have this hybrid model that kind of picks on the both. And when we talk about privacy and controls, the immutability of the data that goes into the blockchain ledger is where we're talking about this, where the immutable properties via cryptographic hashes, and all the blocks are tied to each other in chronological order. And if you make change, and if you try to change any of the data, you won't be able to. It just won't allow you to modify or delete it. And there's certain things that we'll talk about at the end which allow you to at least try, but it's not economically viable. And then at the same time, we also have privacy and controls, where most blockchain networks are developed via asymmetric cryptography, which basically means that the encryption of the data, where you see at the top of the screen is where we're putting in regular text of information, and at the bottom it's generating the hash. You have a public key and a private key. And in order to unlock this, you're going to need both. Okay. And some blockchains have privacy features native to the platform. For example, this is an example of Hyperledger Fabric, where there's different channels that you can build into the blockchain architecture, so that if you have in channel 1, participant A and B can interact with each other and C can't see it. And channel 2, B and C can interact and A can't see it. And then channel 3, A, B, and C can interact and everyone can see all the transactions. Or at the same token, we also have, for example, the Quorum infrastructure, which has Quorum nodes, which are public nodes, and we have Tessera nodes, which are more private nodes. And then when we're talking about the permissioned blockchain side of the world, there's different privacy and controls, and we talk about, for example, there's this user interface that I'm showing you in the top screenshot of the Azure Blockchain Service that allows you to invite participants into your network. So if they don't have the invite, they can't get in. And then there's also a legal bylaw and framework, so that if there's any corruption that happens, you're at least covered within the legal confines. So when we're talking about the smart contract, I know we have just a couple minutes, but let's go ahead and breeze right through. Let's talk about what is a smart contract. And it's essentially a code that is deployed to the blockchain and all the different nodes, and everyone knows that this is the process that we're going to be following. And as different application users, either through your ERM or supply chain management solution, or the point of sale, you're capturing all this infrastructure, and then any of the transactions that are happening are then being tracked over to the blockchain, and it's the smart contract that's enabling all this to happen. And just to give you another visualization of what a smart contract is, it's essentially a business process. So for example, here's a business process. We're not going to go through it too much, But basically, we start at the beginning of a trade or beginning of a shipment, and at the end is a shipment complete, where you have these different stages and different participants at different stages of the supply chain. And this is the process. Again, there's no blockchain part of this one, and there's no coding involved. And you can probably understand from plain text what's happening over here, right? You're hitting different clearances, shipment is in transit, we're covering the shipment, and we're going to go ahead and shipment is complete. And all that is captured within the code. So again, what makes smart contracts so secure is that by leveraging blockchain's immutable values, and once deployed, smart contracts are not able to be altered. Thereby, it's locking in the business logic. So we're all agreeing, say you say that you're in a private blockchain network and you have 6 different participants within your supply chain, and you want to agree and set in stone a certain business process that's supposed to meet various conditions, such as temperature of shipments and sustainability of such. And you can do that and lock that into the blockchain network. And that 100% certainty that this is the same code that's been deployed across multiple participants, where if you were using, say, a regular script or a regular code, and once they take the code and they put that into their network and you rely on each other, you don't necessarily know with 100% certainty that that's the same code and it hasn't been altered. And then at the same time, right? So there's new tech. With this new technology comes new languages. So this is kind of a smart contract is essentially a computer program. So what needs to be done is that you need to now check for the different vulnerabilities and the different security implications of each specific smart contract that's being deployed. And, smart contracts have been around, I guess, since the 2015 era. That's where Ethereum and the Hyperledger projects and where it all started. And since then, there's been an extensive amount of research that has gone into it. And there's, unfortunately, up to this point, there's been, some hacks that have happened due to smart contracts not being programmed the right way, but they kind of paved the way for us today. Is now there's certain tool sets in place that allows you to run your code, run your smart contracts, and outputs the different vulnerabilities. So, for example, the other month, Microsoft put out that they partnered with the Microsoft research team to come out with a very tool basically to run against your Solidity smart contracts, where essentially you put in the Solidity program, it marks the different assertions, and it translates the information into what they call boogie language, a boogie compiler, and then it outputs whether or not that this is fully verified or it's verified up to K transactions or X transactions, and it gives you a way that you can trace the different violations. And this is just one of the tools. And there's a couple different tools that we can recommend and point to that are existing in the ecosystem. Also, there's what we call second layer privacy, such as zero knowledge proofs, which is implemented within smart contracts. And really, they sit on top of the blockchain ledger. But just to give you an example, that if A wants a credit score checked by B, right? So B issues the credit score. Well, the way that you could do it right now is that A submits bank statements where B can see all the history. And you may not want that level of transparency, right? So what can happen now is with the second layer of privacy within this blockchain network is now we have this zero knowledge proofs, ZKP for short, which basically says critical data variables and rules have been predefined, so no data actually needs to be sent. And this is all done via algorithms and different codes within smart contracts. So just kind of providing a little bit of a recap over here. What are the common threats to applications that leverage blockchain technology? Well, there's 51% attacks. And 51% attacks, obviously, it's mitigated through having a large network. The larger the network, the more computational power it'll take for the 51% attack to happen. Likewise, in the private blockchain space, where there may not be thousands of nodes in the system, there may be 6, 7, 8, 9, 10 of them. They're still held within a legal confines where, okay, it's still a little easier to go ahead and perform the 51% attack, but at least you're protected by the legal confines. There's endpoint vulnerabilities, which has been addressed through the smart contract and also the smart contract vulnerabilities where you have this different testing software. Endpoint vulnerabilities also are addressed via the cloud platform and the security measures that the AWSs and the Azures take. At the same time, private key security is something that still needs to be worked on, but essentially private keys is something that is a user error type of an issue. So when users essentially are misplacing their private keys, that's where some of these hacks that you've been reading about has happened. Blockchain does not make all data good, right? So if you're taking information from a bad data source and you're bringing it in, it still is going to trigger workflows that aren't necessarily on the true golden source data that we're looking for. There's been some thoughts that quantum computing in the future will be able to provide the computational power to perform these 51% attacks. But just today, there was a new article saying that just like quantum computing is a threat, well, the answer is quantum blockchain. So look, I mean, as the technology increases, we're always going to find new tricks. And then user wallet hacks kind of sits along the same time with the private key securities, and the DDoS attacks also can be addressed via the cloud platforms. So just some final words over here. So you know, popular cloud platforms like Azure and AWS have already been approved in different organizations. So you're already one step to having that sort of security of what you're looking for. The majority of hacks to blockchain applications have been human error to code and application layer vulnerabilities. And then also some of the characteristics that make blockchain so great are the features that bring on the most amount of risk. So inherently that we may want certain things to happen, but we have to give certain things away, such as the ability to not reverse transactions, right? Once something goes into the ledger, it stays in there forever. So these are some of the things that if we really want this sort of technology, we got to be able to work with that. So thank you so much. I know that we went over by a couple minutes, but really appreciate your time. Again, if you happen to go to envisionblockchain.com/enterprise-blockchain-immersion, we provide a much longer, more in-depth, educational workshop to help you understand all the different terminology that we quickly discussed in this 30-minute presentation. We also provide different smart contracts and different applications for you to put your hands on and really get a good feeling as to what this blockchain technology can really do for your business. So thank you so much. We really appreciate everyone joining.